Welcome to solverfy.
This is the answer to Chapter 16, problem number 41 from the Smith Organic Chemistry textbook. And in this problem, we're given these four dienes, and we are asked to rank them in order of increasing heat of hydrogenation. And so what I'm going to do is number one is going to be the lowest heat of hydrogenation, and I'll call number four the highest heat of hydrogenation. So rank them 1 to 4 in order of increasing heat of hydrogenation. And so in order to do that, we need to remember that a less stable double bond is going to have a higher heat of hydrogenation. And then we also need to recall that the more substituted a double bond is, the more stable it's going to be. And so looking at the first molecule here, this is a conjugated diene. So conjugated one of these double bonds is tetra-substituted. So we have one tetra substituted, and then the other is di-substituted. So one tetra, one di-substituted. Okay, and so that's probably going to be a pretty small heat of hydrogenation. That seems like a pretty stable system there, but we should look at the others so that we can make good comparisons. And I'm actually going to just move everything over a little bit. Oops. All right. All right, there we go. Get the eraser working. Okay, so tetra and di-substituted. Okay, so then let's look at the next molecule. So this molecule is isolated, so it's not a conjugated diene. So it's isolated, and then we have one di-substituted and one tri-substituted. So di and tri, and so I'm not going to write substituted out again. So one di-substituted, one tri-substituted, and so that's going to be a higher heat of hydrogenation than the first molecule. So looking at our third molecule, this is a conjugated diene, so that's good for its stability. So this one's conjugated, and then looking at our double bonds, we have one di and one tri-substituted again. And so di and tri. And so the third molecule here is going to be more stable than the second molecule, and it's going to have a lower heat of hydrogenation because of that, but it's not going to be as stable as the first molecule. And so then let's look at the last molecule here. So this is an isolated diene. Obviously, the double bonds are on opposite sides of the molecule. They're not in conjugation. And it looks like they are both di-substituted. So both di and isolated. And so this is going to be number 4. This is going to be the largest heat of hydrogenation. And the first molecule is going to be number 1. It's going to be the smallest heat of hydrogenation because it's conjugated and it's pretty highly substituted. So then looking at the two middle molecules, they're both di-substituted and tri-substituted, but one is isolated and one is conjugated. So the one that's conjugated will be more stable, and the one that's isolated will be less stable. So the order here is going to be 1, 3, 2, 4. Again, I've assigned 1 to the molecule with the lowest heat of hydrogenation and 4 to the molecule with the highest heat of hydrogenation. And again, I arrived at these assignments by looking at conjugation versus isolation of the diene, and then also looking at the substitution pattern around each double bond. And remembering that the more substituted a double bond is, the more stable it is. And the more stable a molecule is, the lower heat of hydrogenation it will have. And that's the answer to chapter 16, problem number 41.